Hello guys, my name is Yusra and today I'll be going through the case scenario which is an e-hailing app called Malaysia Travel. This app has been designed for the residents of Kuala Lumpur since traditional taxi services are declining due to technological advancements. The two main objectives of this app are to connect users with nearby drivers in real time and to improve transportation efficiency and user experience in Kuala Lumpur. The main goals of this comprehensive service are to make Malaysia Travel a leading e-hailing platform and to provide a secure and efficient ride to our users while enhancing user satisfaction through feedback and insights. The app works as follows. Users, that is riders, can download the app, create accounts, and request rides by entering pickup and drop-off locations. Drivers can also download the app, create accounts, and must pass a background check before accepting rides. The app calculates fares and tracks journeys in real time. After the rider's journey is completed, he can rate both the trip and the driver for other viewers to view. By designing a comprehensive relational data model and implementing a database, the service Malaysia Travel will for sure improve user experience. The database will monitor the rider's journey, generate insights based on the user feedback, and offer many more services.
Good morning everyone, I'm Chong Chun Yin. Today I'll be explaining business rules and constraints. Let's start easy. Users are divided between drivers and riders. This is simply to make a distinction between the providers and the consumers. To clarify, rider book rides and driver offer services. Without this, the platform doesn't know how to allocate resources and design its features. Next, both the rider and the driver need one account, at least one. Every user needs to be authorized to use the platform. This is for security, accountability and personalization purposes. This also tracks user activity like rides, booking history and payment methods. Everything is tied to their accounts. Alright, drivers must undergo a background check before account registration. Safety for passengers is our top priority. One bad apple will ruin the whole platform, and without customers, there will be no business. So, background checks are mandatory for drivers. Riders need to feel safe when stepping into a stranger's car. This helps to screen out drivers with criminal records or unsafe driving records. Now, riders should have at most 3 payment methods. This is to not overcomplicate the system and the users. 3 methods strike a balance between flexibility and control. We believe this will minimize fraud and make transactions easy and seamless. After that, drivers must have at least a 4.0 rating to prevent license expiration. Apart from review bombing, we will ensure that the rating system is the penultimate way to ensure service quality, and anything below that signals inconsistent issues. And we can't compromise on quality. Then after that, riders can cancel a ride without incurring a loss if the driver is taking too much time. Time is valuable. Time is money, and taking too much time is taking away customers' money. So compensation is imminent. Delays can cause dissatisfactions, and a penaltyless cancellation for delays can lower frustrations and increase fairness. And lastly, for business rules, riders must submit a feedback form after every trip. We need a feedback loop to continuously improve the quality of both the drivers and the riders. Now, onto constraints. Foreign keys. Foreign keys act as a bridge between data. A ride is linked to a ride and a driver using their IDs. Without this, it will lose its structure and become untrackable. Next is referential integrity. This makes sure that all the related data are consistent. This tries its best to prevent anomalies from happening and to keep the database clean and logical. Not null. Some primary fields like user ID cannot be null. Without this, the database will be plagued full of ambiguity. Check is to reinforce the data validity by checking invalid entries and align with our business rules. Lastly, unique. Certain fields like email and phone numbers must be made sure that each user is identified individually. This is to prevent duplication and fraud. This wraps up my part, and now I pass it to my next teammate. Thank you very much.
Hello, my name is Marcus, and now I'm going to explain the ERD diagram. Firstly is the user table. User table acts as a parent table with a user ID that serves as a primary key, related to driver and rider tables through a user ID. Secondly, driver and rider tables. Driver and rider are extensions of the user table, representing specific user types. Driver has additional attributes like rating, plate number, and phone number. Rider includes attributes like phone number and email. Third, ride table links driver and rider table using driver ID and rider ID as foreign key. Track ride details such as pickup, drop-off, distance, and completion. Fourth, payment table linked to the ride table using ride ID as a foreign key, associated with the payment mode table through model ID, which defines the payment method. Example, cash, credit. Fifth, payment mode table stores different modes of payment with model ID as the primary key. It is connected to the payment table and indirectly associated with rides. Sixth, checking table tracks the validity of driver with driver ID as a foreign key, ensures compliance and maintains driver status. 7. Rating table allows riders to leave reviews and rating for a specific ride using ride ID and rider ID as foreign keys. 8. Account table associated with user through user ID, storing additional account-related information. We also have a driver mode junction table, which is used between driver and payment mode using driver ID and model ID as composite primary keys. It represents the relationship where drivers can support multiple payment modes. The driver mode table bridges the many-to-many relationship between driver and payment mode. Each driver can support multiple payment modes such as cash, card, or digital payment, and each payment mode can be associated with multiple drivers. This junction table ensures that all such combinations are tracked effectively while normalizing the database design.
Hello teacher, I am Matthias Ong. I am presenting the table creation as well as insertion of data. Here we have the user table with its user type, the password name, and user ID. And we have rider table and a driver table. Here, as you can see, we have the user ID as a foreign key, as the user table is like a parent table to the rider and drivers. Moving on to account. Account is more of like the information stored from the user into the account table. And here we have checking table. The checking table is to check the validity of the driver, whether they are valid to be able to take customers, take riders, for example. So ride has the driver ID, the rider, as well as the pickup location, the drop location, and the distance, and completion time and order time. This is when a rider will book and a driver will accept, then all these details will be inserted into the database. Now we have ratings. The riders have free will to rate the drivers that they have taken the ride off and able to give them the comments about it, as well give them the stars to rate them. Moving on to payments. Payments, here we have the mode ID as well as the mode name. Well, payments is more of how the riders want to pay, either with a card, cash, or internet banking. Payment is where the actual payment happens, where the rider will then give the amount details and stuff. So, the ride ID is where all the information of the distance, as well as like how much it will cost because of this distance and stuff like that. And then we have driver mode, where this is where the driver is being paid, as well as the mode ID of the payment. That. Here we have user insertion data with their passwords and the user roles and the names and the user IDs. Here we have rider with their rider ID, the user ID, phone number, and email address. And this is the driver table with driver insertion data, where it has their driver ID, their user ID, or their ratings, their license plate for their car, their phone numbers, and their email addresses. Here we have the account where it's all lined up with the users. Checking. This is checking the validity of the drivers. Right here. And this is all the riding insertion data, where it's going to Sunway University, we can tell you the distance there, especially the time it happened. Moving on to the ratings of the riders, giving the ratings of the drivers about the car, the ride, how was the experience, and then payment modes, how of course, the insertion of data of payment, where it's either the internet banking, card, cash, however the rider wants to pay. And then we have the actual payments of the ride being noted down here, and then to correlate that, the payments of it's following the driver mode of the drivers being paid for it. And that is all I've been presenting. Thank you for listening to our presentation.
Hi, my name is Isabel Young, and I will be covering the last section, which is the SQL query demonstration. So the first question, the requirement was an outer join. So for our SQL command, we wrote a query to retrieve the name and IDs of all drivers along with their rides history, including drivers who are registered but have not completed any rides yet. So here, name and IDs, driver ID, driver name, and then the information about the ride. So all this from this one table. And to include drivers who are registered but have not completed any rides yet, we use the left outer join. So here, I'll just run it to check. And here it pulls up. Yes. Right, okay, including the drivers who have not completed any rides yet. So that showcases the first question. Moving on to the second question. The second question, the requirement was a minimum 4-table join and a group by function query. So two things, a 4-table join and minimum 4-table join and the group by function. So we wrote a query to display the total amount owned. So we wrote a query to display the total amount earned by each driver on each payment platform and group the information by respective payment mode. So by payment mode, we mean, say, cash, card, e-banking, etc., etc. So here, select driver info, and for total amount earned, we use sum and p total amount. Next, we also have the mode ID and the mode name to identify each payment platform or like each payment mode. So here, for the 4-table join, we actually did a 5-table join. So the 5 tables are payments, ride, payment mode, driver, as well as users. And finally, for the group by function, we group by all these non-aggregated attributes. So we're just going to run it very quickly to check. Right. And here is the results, complete with the mode name and everything. These are the total earnings. Right, okay, moving on to question number 3. The requirement for question number 3 was a string pattern matching and a date function query. So for string pattern matching, of course, we use the word like in our query, and thus we wrote a query to display all reviews made in a specific month. We chose the month of June, where the writer talked about the car. So reviews that talk about car, so we wrote a query where the comments, as in the reviews, include the word car. So we use the percentage symbol and the word car with spaces so that it doesn't detect words that just have CAR in the middle of them, and specifically the word car itself. So we use the word like for string pattern matching, and for the date function, instead of to date, we use to car because it's only specified one component of the date, which is the month. So we use to car instead of to date. This month, 6 for June, right? So let's just run it very quickly to check. Okay, and we have these two, both in the month of June. Mentioned the car is super clean, car was clean, that's great. So now moving on to question number 4. Question number 4, the requirement was to have a query that used both or as well as and operators. So for that, we wrote a query to retrieve drivers who drive cars that are either from Selangor, where the license plate starts with B or V, or KL territory, federal territory, where the license plate will start with a W, and have a rating of less than 4.7 stars. So for this, for the license plate, we used 2 ors and 3 likes for string pattern matching. So there's ors and there's the and for the rating. Okay. All from the same table, so there's no need for the join. Right, okay. So these are all with the ratings, all below 4.7. And all from either Selangor or KL, W, B, W, okay. Or. Right, okay, so that's question number 4. Now we'll move on to question number 5, which was one of the more challenging ones, more bugs. Right, so question number 5, the requirement was to have at least 2 subqueries. So for this, we wrote a query to find the total payment made for rides rated 4.5 stars and above, grouped by the driver. So in this, we have not 2 but 3 subqueries. The first subquery is this select count, which is for calculating the number of total completed rides. The checker that we used to find this was the completion equals y, and yeah, right. So, and the second subquery is sum total amount to find the total payment, or like the total earnings, right? And the final subquery is for the rating section, where it is rated 4.5 stars and above. Right, okay. Let's just run it very quickly to test. Okay, these are the results. No bugs this time. And finally, we're at our last question, which is a case question. So the case question was provided based on which case scenario that we chose. Our group chose to do EHailing. So we were given the final question, question F, of provide a list of drivers who have completed the most trips within the last month and have a rating of 4.5 stars or higher. So here we have the case question and the command that we wrote for it. So select driver ID, driver name for the driver info, and then for number of trips, we chose to do count ride ID because each ride has its gets its own ride ID. So 2 different rides will get 2 different ride IDs. So the logic seems pretty sound. We use that to calculate the number of trips, and then finally we have the rating. And next we have this where for the completed the most trips within the last month. So it's from November to December. Right. Okay. And then finally the rating 4.5 stars or higher, grouped by non-aggregated attributes. So let's just run it very quickly to check. No bugs. Yes, so that is it. That's SQL queries A, B, C, D, E, F for our project, and that concludes the section for the SQL query demonstration.